The question that I have is, could you solve a truss problem by the method of section? This is the problem that I have selected here. The question is to find the forces in members AB, CD and AC. We're going to do this by the method of section. Our first step is to examine the truss and see if there are any zero force members. By the criteria that we have established earlier in another video, there doesn't seem to be a zero force member on this truss. However, keep in mind that those criteria do not cover all possibilities. In fact, when we are done with it, we're going to find that the force on one of the three members that we are interested in is zero. The second step is to section the truss in an optimal way. The key guideline is that we should section the truss in such a way that it does not cut through more than three members. Of course, we should cut through members that we are interested in finding the forces on. On the basis of these two reasoning, this is the optimal sectioning. Next, we need to select a part to analyze, and here we will select the top part. If we were to select the bottom part, we need to first find the support reactions at these pins, which are not easy to find. Let's first go ahead and complete the necessary geometrical details. We note that this little triangle, this triangle, and this big triangle are all similar triangles, right? Since these dimensions are equal to each other, this will be 1 meter and this will be half a meters. In other words, since 2 meters is 1/3 of the 6 meters, this dimension is going to be 1/3 of 1.5, which is half a meters. And since this dimension is 4 meters, which is 2/3 of 6 meters, this is going to be 2/3 of 1.5 meters, which is 1 meters, right? The truss is symmetric about the vertical center line. So everything that we have on the right side of the center line is identical to what we have on the left side. In other words, they are mirror images, right? Alright, so with that understanding, now we can find values for angle theta and alpha. Theta is tan inverse of this distance, which is 2 meters, divided by this distance, which is 1 minus half, which is half, right? So we get a value of 75.96 degrees for that. Alpha would be tan inverse of this distance, which is 2 meters again, divided by this distance, which is 3 plus another half, 3.5, right? So we get a value of 29.74 degrees for that. Now we are ready to use our equilibrium equations to find the unknown forces. Here I am writing down a moment equation about point C. I am resolving this force FAB into horizontal and vertical components. The vertical component is FAB sine theta, which is directed downward from point A. And the perpendicular distance of that from point C is 3.5 meters. And we have a counterclockwise moment, so that goes in as a positive term in this equation. The horizontal component of that force is FAB cosine theta, which is directed in the negative x direction. The perpendicular distance to the line of action of that force is 2 meters from point C, right? And that also gives me a counterclockwise moment. And this 20 kilonewton gives us a counterclockwise moment as well. Perpendicular distance to that is 3 meters. This 20 kilonewton also gives us a counterclockwise moment. The perpendicular distance from point C to that force is 1 meter. After rearranging and simplifying, we get a value of minus 20.6 kilonewton for FAB. Next, I take a moment about point A. The three forces that could potentially make a contribution to that equation are FCD, this 20 kilonewton, and this 20 kilonewton, right? The horizontal component of FCD, however, passes through point A, and therefore that will not make a contribution to this equation. Only the vertical component will. Here are the details, and I get a value of minus 20.6 kilonewton for FCD also. That is, I get the same value as the force on FAB. Next, I sum up the forces in the vertical direction. After simplifying, we find that, accounting for numerical rounding, FAC is 0. Remember what I mentioned earlier, right? One of the three forces was going to turn out to be 0. And this is that force, FAC. We couldn't have predicted it using the two criteria we established for identifying zero force members. So keep that in mind. The two criteria do not cover all cases. So we found everything we were asked to find. Here's a summary of the results. Since we ended up having negative numbers for FAB and FCD, they are actually compressions.